Okay, so here's our part, and we're going to want to see if we can make some changes to it in a nice systematic way to get to just the right answer, to reduce as much weight as we can, hopefully getting down to that 5.5 pounds. So we're going to go back into our stress analysis right there, but we're going to do a new study this time. And instead of a single point, we're going to use those parametric dimensions. So it's going to be a new one. It's still static, but it's parametric dimensions. And to see those parametric dimensions, we have to right click on the body and show the parameters. And they're showing up on the wrong screen, but here they are. And so we're going to work with that wall thickness and the flange thickness. And you can see we're right now at 0.25 and 0.5. So there we go. And in the parametric table, we're going to want to say we're going to look at the safety factor. So the safety factor should be white. And here, the current value is 0.25, but we want values that are less than that. So I'm going to go in front of it and I'm going to go all the way down to 0.125, comma, 0.155, comma, 0.185, comma, 0.215, comma. And I'll just see, and I need a comma there. And I'll just see it's going to test all of those. And then it's also going to test, whoops, must be in ascending order. I thought I had them in ascending order. 0.125. 125. 0.155. 0.185, 0.215, and 0.250. There we go. And down here, I'm going to start as low as 0.250, 0.375, comma, 0.412, comma, 0.460, comma. I'm just picking some. Those are in 8th and 16th increments. So there we go. It still didn't like those. It's having troubles. I'm having troubles. 0.375, 0.412, 0.460, 0.5. Those are in order now. And so it's going to do every combination of these and see if it can do it. So I'm going to check my material again. Yes, it's ductile iron. I'm going to I have to do a new one of these because I'm doing a new study. So I'm going to take the location as that flange face. Okay, and there's my little marker. I got to put my pressure in here again. It's 300 psi. Click. And I'm connecting all those surfaces. And let's just see what happens. Run. It's going to take a little bit longer this time. Remember how fast it came out last time. So there it is. And so look, I can start moving this little slider down here. There's a slider and I can just move it to the next spot and the next spot and the next spot. You know, maybe I can type a 2. No, I can't type anything in there. Add design constraint to a safety factor. Minimum value. Min safety factor of 2. No, I don't like that. So I'm going to back that up. Okay, so here we go. Here's our safety factor. And as I move these, I'm still having a pretty high safety factor. Oh, that one's not available. I can't do that combination. So I have to come back over here. So 0.185 and a 0.5 seems to be pretty much about it. Let's see if I go a 0.215, 0.46. Nope, still not going to make it, even down there. So it looks like I can't get too much smaller in here and still have this thing work well. Okay. So here it's showing my safety factor is still pretty high, and here it just goes away. It's not available. See if I can go one size smaller. I can go even a little bit smaller, 0.155. What's my safety factor now? 12. And I can get down to a 3. So I can go as thin as 0.125. Let's see if it's all the way thick if I can get one. Ooh, but maybe I can, with this at 0.25, ooh, this might be better for me because I can get all the way down to a 0.375. But then I start losing it. Probably because of some of this geometry not quite working right. If this is too thin and this is too thin, this area in here might be falling apart and not doing a good job. So I could do a 0.375 with 2.25 thick, or a 0.41 with 0.25 thick, or a 0.375. So all of those start making it too small, but that would probably save me the most weight. A 0.375 thick flange and a 0.25 thick there. So I've got two things to try. 0.375 and 0.25 and a 0.5 and 0.125. Well, I can just look at that, how much material. It's far better to get rid of flange than it is to get rid of this. I can just see, but you can test it out. So I'm going to go 0.25 cone thickness and 0.375 on the flange. So here we go. 0.375 flange thickness and my cone thickness 0.25. Let's see now what I get. Almost there. Almost there. So I can probably do just a little bit more and take a little bit out of this and see if it still works. Oh, you know where else I can take it? I can take it out of that. That's a big chunk. Stem hole, boss diameter. Now let's see how much I weigh. So this is how you go about getting yourself really, there it is, 5.492. I made it. and I'm sure everything is going to work because I've already tested it out. So I've got this, I've got this, I've got this. Let's go and back to my static analysis 1 and simulate it and just make sure that I've got everything right. Yeah, it's still plenty strong. Look at that. Still plenty strong. Cool? That's how you use the parameters and the systematic parameter table system.